Let's give a counterexample to show that the division algorithm is false for z square bracket x. Now, why is it going to be false? Because z is not a field. The set of integers has the operations of addition. There's an additive inverse. There's an additive identity. Addition commutes, and addition is associative. The z also has the operation of multiplication, which distributes with addition. And there is a multiplicative identity, and multiplication commutes and multiplication is associative, but there's one property that does not work, namely that there is no multiplicative inverse inside of the integers. So the multiplicative inverse of 3 is 1/3, and 1/3 is not an integer. So if I looked at the field of rationals, that would be a field, but the set of integers is a ring which does not have a multiplicative inverse. So to give a counterexample that shows that the division algorithm is false, let's do something fairly simple. Let's let a of x be equal to x squared, and let b of x be equal to 2 times x. Okay, so the idea of the division algorithm is to see if we can find unique polynomials q of x and r of x, so that a of x is equal to q of x plus r of x, and r is either the zero polynomial or else the degree of r is less than the degree of b. In other words, the degree of r must be equal to 0 because the degree of b is equal to 1. Okay, well, let's see, how are we going to make this work? X squared equals, well, 2x. Clearly, I can multiply 2x by 1/2 x squared, and 1/2 x, pardon me, 1/2 x, and I end up with x squared, and r is the zero polynomial. Okay, so that would be the apparent quotient and the apparent remainder, except for one important thing, that the quotient that I found is not an element of z square bracket x. It is an element of q square bracket x. It has a rational number as a coefficient, but it does not have an integer coefficient. So the division algorithm is false if I restrict myself to coefficients that are integers. However, if I allow my coefficients to be rational numbers, then the division algorithm is correct.